Hello everyone, today we are going to see about the differential equations. What is a differential equation? These are the equations of the similar type that you have gone through in your lower classes, like quadratic equations, then you can say unequal equations, equations related to the inequalities, right? So same way here we have a differential equation. You can identify the differential equation with the some differentiation term. So differential equation has a differentiation term, some sort of differentiation, you will be seeing in this type of differential equation. Let's take an example. So let's say if I write down as dy by dx whole square plus 2y is equals to 3. So this is a differential equation. We have equal to sign, so it's equation and there is differential term. So it helps us to identify the differential equation. Another way to identify a differential equation which we are involved with is it has a one dependent variable and one independent variable. So if you see dependent and independent variable only one time in the equation, we call it as a again a differential equation. So here you can see that we are associated with y and x. So this equation, when it gets solved up, it may appear in the form of something of this form, like ax plus you may take some constant c. A and c are constant, right? So in this equation you see y, it is a independent variable, sorry, it is a dependent variable because its value will depend upon x, and x, it is a independent variable. So when there is one dependent variable and one dependent and one independent variable, right, such type of differential we call it as a ordinary differential equations, which we are interested in this part of the chapter. Ordinary differential equations look somewhat like this. There is a one differentiation term, at least one differentiation term, right? It has one dependent and one independent variable. From here to here, how it has come, we'll go through as we discuss the chapter. Then next we have linear differential equation. So linear differential equation, it is the one which has highest degree as 1. If the highest degree of the differential equation is 1, we call it as a linear differential equation. Let's see what do we exactly mean by the degree. So here, related to the differential equation, we have two more terminologies, that is order and other one is degree. So what do we mean by order of differential equation and what do we mean by degree of differential equation? So order of differential equation, it means the highest order of differentiation that is involved in the equation, and degree of the differential equation, it means the power of highest order of differentiation. So whichever term has a highest order of differentiation, its power, we call it as a degree of differential equation. So if we take this differential equation dy by dx plus 2y equal to 3, in this one we see that the highest power of differentiation is 1. So for this equation the order is 1. We see only the first order derivative, and this first order derivative, it is raised to the power 2. So degree of this differential equation is 2. Let's take few more examples. Let's say if I write down as 4 dy by dx whole square minus x square equal to 0. So here also if you see, in this case the highest order of differentiation involved is 1 and the power is 2. So here also we have a degree of this differential equation 2, and yes, it is a differential equation, right? It involves a differentiation term, and similar to this, the solution of this differential equation will come in some this format, and in this format we can for sure again get to know that there is one independent and there is one dependent variable. So in this chapter we are dealing with ordinary differential equations which has one independent variable and one dependent variable. Let's take another example. If I take d2y by dx square minus 36x equal to 0. So once again here, if you analyze this equation, it has a order 2, right? The highest order of derivative is 2, and it has the power, highest power is 1. The second order derivative, it is raised to the power 1. So the degree of this differential equation is 1. Then next we have solution. How do you find out a solution of differential equation? So to find out a solution of differential equation, right? To find out the solution of differential equation, you must integrate, and with some mathematical manipulation, right, you can bring it to this level. Apart from solving a differential equation, there is also one part which we see, that forming a differential equation, or you can say framing a differential equation. If you want to frame a differential equation, let's say you have been given this, right? So in this differential equation, this one, from this, if you want to form a differential equation, what to do? There is one just simple step, that is eliminate constant. If you eliminate this value, that is for sure done by the differentiation, right? Using differentiation, if you eliminate the constant, it will get converted into the differential format. Another important information related to this equation is, if there are one constant, if there is only one constant in the differentiation, unlike here we have 1 and 2, a and c, there are two constants. If there is only one constant, then the order of differential equation is 1, and if there are two constants in a equation, then the order of differential equation is 2. So that is about the introduction of the differential equation. Let's see some examples of the differential equation, so all this concept will get very clear to you. So the first example which I take is y is equals to ax plus 2. This is some equation given to us, right? And from here we have to form, this is some equation, a linear equation is given, we have to convert it into a differential equation. So forming a differential equation, how will you form a differential equation? Eliminate constant using differentiation. So just differentiate it, dy by dx, right? Differentiation of ax will be a, and differentiation of 2 will be 0. So the value of constant I have found out, resubstitute it in the original equation, right? And here you have a differential equation. So here you can see the order is 1 and degree is also 1. So when order is 1, degree is 1, right, we have one constant a, so order of this differential equation should be for sure 1, and we have verified over here. So we want, next we have, let us try to find out the differential equation of a circle, right, whose radius is given as a, and they have said that center lie on x-axis, let's say positive x-axis. So how will we form a differential equation of a circle whose radius is given as a and its center is lying on the x-axis? So you, for to solve this question, you must know that the standard equation of the circle is x square plus y square is equals to a square. This is a standard equation, general equation of a circle. So this equation get modified as per this condition, and as per the given condition, the radius a, right, this is the equation where the radius is a and the center is at origin 0, 0. But as per our question, the center is somewhere on the x-axis. So the equation gets modified as x minus a square plus y square equal to a square. So this is the equation related to the question. Now this equation we will convert it into a differential equation. So once again, same thing, eliminate constant using differentiation. So we'll try to eliminate, here we have one constant a, so let us try to eliminate using the differentiation. Differentiation would be 2x minus a plus 2y dy by dx, and the constant when we differentiate we get it as 0. So here we have a differential equation plus y dy by dx is equals to 0, right? X minus a is equals to minus y dy by dx. We'll find out the value of a and resubstitute in this equation. So a minus x is equals to y dy by dx. I have taken negative common from both the sides. Y dy by dx plus x. So this is the value of a. So let us substitute the value of a into the differential equation which we have, that is x minus a. So y dy by dx plus x whole square plus y square is equals to a square. So instead of a, its value we have substituted here. If we open the bracket, x minus y dy by dx minus x whole square plus y square, and this bracket square as it is, plus x minus x gets cancelled. The square of this would be y square, and dy by dx whole square plus y square is equals to y dy by dx plus x whole square. If you want, you can still open up the square and write it further, but this is the differential equation of a circle as per this given condition. Let's open up the bracket. It would be y square dy by dx whole square. This side will be a square plus b square plus 2xy dy by dx. So here this term and this term gets cancelled. So y square minus x square is equals to 2xy dy by dx. So this is the final equation for the circle whose radius is a and center lies on the x-axis. Let us see the next question. So this is some equation of the power 2, right? And this equation need to be converted into the differentiation form. So here we have constant, only one constant we have, so it is a ordinary differential equation. We'll try to convert it into the differential format. So if we start by differentiating, you can also open up the square bracket and then differentiate. I'll differentiate it directly. So 2cy plus c dy by dx, and this side it would be 2x, right? And then multiply and dividing by y plus c. I want to eliminate it somehow. You can use your own methods. I'll use my own. So multiply and dividing by y plus c. So the equation will become 2cy plus c whole square and y plus c dy by dx is equals to 2x. 2 gets cancelled from both the sides. So we can see here c into y plus c whole square. This numerator can be rewritten as x square. So x square by y plus c dy by dx is equals to x. 1x gets cancelled. X dy by dx is equals to y plus c, and the value of c would be x dy by dx minus y. So let us substitute this value into the original differential equation. So x dy by dx minus y and y plus c. So x dy by dx minus y, which is equals to x square. So plus y minus y gets cancelled. So here we have x dy by dx minus y and x dy by dx equal to x square. 1x gets cancelled. You can multiply dy by dx inside. So x dy by dx whole square minus y dy by dx is equals to x. This is a required differential equation for this given equation.